Alright, so I want to talk about the limit definition of the derivative here for a few minutes and do a example problem with kind of a somewhat tricky function that'll give us a bit of room for error. So let's do this. So if we remember, the limit definition of the derivative just says that f of x is equal to, f of x is equal to the limit as h approaches 0 of f of x plus h, looks like a b, doesn't it? F of x plus h minus f of x, all this just over h. So this right here is the limit definition of the derivative. So we're going to be using this formula to do our work here. And the function I'm interested in today, I want to use this to calculate the derivative of this function. F of x equals x squared minus a rational 3 over x. So this is what I want us to figure out the derivative for. This guy right here. So what do we need to do? Well, let's think about it this way. If the limit definition of the derivative is the limit as h approaches 0 of f of x plus h minus f of x over h, then that means that f of x plus h, well, we can go ahead and rewrite it this way. Instead of just f of x, what's our f of x plus h? Well, our f of x plus h, since this was our original formula right here, the x squared minus 3 over x, well, f of x plus h would just be equal to x plus h squared minus, and moving this rational into a new rational, 3 over x plus h, right? Because everywhere we have an x, we're replacing that with x plus h. So we can go ahead and rewrite things this way to make life a little bit easier for us. And now that we've done that, we can go ahead and start plugging things into the limit definition. So let's go ahead and rewrite our limit definition. F prime of x is equal to the limit. No, I don't have a prime there, do I? There we go, f prime of x. The limit as h approaches 0 of f of x plus h minus f of x over h. And so let's start plugging things in. That means now that we can say all this is equal to the limit as h approaches 0 of, well, we're just going to have an h on the bottom, so let's just go ahead and write out a big long rational and put our h on the bottom. And now we're going to really need some serious bracketing on the top here. So we're going to have the limit as h approaches 0 of, well, x plus h squared, right, minus 3 over x plus h minus, now we've closed those brackets and we're going to open some new parentheses on the right hand side of this difference, minus x squared minus 3 over x. Now you see what we've done here. We wanted to figure out f of x plus h like we did up here because that just makes our lives easier. Everywhere we see an x, we would plug in an x plus h. But we can make that process easier by figuring out what f of x plus h would be to begin with. So now that we figured out that f of x plus h is x plus h squared minus 3 over x plus h, when we go to plug things in the limit definition of the derivative, the f of x plus h part is a lot easier, and it just immediately turns into what we got up here, the x plus h squared minus 3 over x plus h. So that's pretty easy. So now we need to just start simplifying things. So here's what we need to do. In order to do this, well, let's go ahead and just break things out from right here. Let's go ahead and turn that into something else and get rid of this rational and that kind of thing, move things from one side to another. So I'm going to skip a few steps here algebraically, but see, I'm carrying this over in my head, so forgive any mistakes. I will go back and check myself. So this should be the limit as h approaches 0 of, and we should just keep our h on the bottom. I'm pretty sure that will still happen here. All right, of, give myself a little more room. So x squared plus 2xh plus h squared, right? Because if we factor this x plus h squared out, If we can do that on paper, but if we just do that in our head, that should not be very difficult to factor out at all. So we should just get x squared plus 2xh plus h squared. And now we should have a minus x squared, right? Now I suppose I'm kind of skipping a step here. What I'm going to do is I'm going to turn this, I'll turn it into what I'm going to turn it into, and then I'll explain why I did this. I'm just going to have an x squared here minus 3 over x plus h minus 3 over x. Okay? So I'm just going to keep these two things on the top. That's all I'm going to do. And here's why I was able to do this, why I'm moving things from one side to another. So you notice all I did was, we've got this x squared here, this 3 over x plus h here, this 3 over x here. All I'm doing is I'm just kind of changing around the order that things are written in. We have a 3 over x plus h right here. We've got an x squared right here. Right here, and we've got a 3 over x right there. So that's all. That's where this stuff is coming from. So nothing is being changed. Once again, it's not an equation. We don't have to change signs or anything. We're just changing the order in which I'm writing stuff. So that's all I'm really doing. So let's take this down. Let's keep simplifying things. This is just going to be equal to the limit as h approaches 0 of... All right, well, let's cancel some things here. We're going to continue to have this nice giant rational, which is easy for us to work with because all we have in the denominator is just an h right now, which is going to go to 0 as the limit definition rule will tell you. So let's go ahead and start canceling some things. Well, I moved this x squared over here for a reason. That was not an arbitrary move. If we have an x squared and a negative x squared, well, these two things, they're just going to kill each other. So those are gone. And now let's multiply this by x. Let's multiply this by x. And then let's multiply both over here, x plus h. We're doing this just to start canceling things. So we've done that, and so here's what we're going to end up with now that we've done that. And I don't think I'm going to actually need a rational that's this wide now. What this is going to give us, and once again, skipping a few algebraic steps here, this is just going to be 2xh plus h squared plus 3 over, and watch closely here, 3h over x times x plus h. Look at what we did. We're just it's this multiplication up here, and this multiplication down here is giving us this brand new rational. So that's all that is. Nothing tricky at all. So, all right, we've got this, and all of this, of course, is still just going to be over h. So what's this going to equal? Well, once again, we're going to have our limit as, I know it may seem silly that I keep writing this every single time, but I think it's extremely important. It's not, worst off, it's not mathematically, procedurally correct to have this rational and keep and saying, with a sign that denotes equality, if we don't have this limit, because 2x plus h squared plus 3h over x times x plus h, all of this over h, this is not equal to what this part right here. It's only equal to this part with a limit. That's why we have to have this limit here every single time, because that denotes true equality. So, and we put that in a rational. Put that rational in some brackets. Okay, so anyway, pardon my aside there. So we're going to have the limit as h approaches 0 of, well, let's go ahead. I think a good idea here is just to factor out an h. So, because we're going to let it go to 0 later anyway, right? So, h times, that would be 2x plus h, because we have that h squared, so 1h is still going to stay in there. Yeah, pardon that noise there for a second. 2x plus h plus 3 over x times x plus h. Now look at what this allows us to do. This allows us to go ahead and cancel out. Well, we've got an h on the bottom here too, right? Can't forget that. Well, this allows us to just let these two h's kill each other. So those cancel out. So h is, of course, we need to remember this. This is important, and it's very easy to forget this sometimes, I think, is that, let's write just a little aside here. H is near 0, but h is never 0. It's never actually 0. So we're letting it go to 0, but it's not actually going to be 0. So once we do that, the limit as h approaches 0 of this big function right here, well, all this is going to turn into, my bad, is just 2x plus, I think, 3 over x squared. Let me check. Yes, 3 over x squared. So that is equal to f prime of x. So we have arrived rather nicely, and it wasn't too tricky of work, at the derivative of our initial function, which was f of x equals x squared minus 3 over x. So that's all there is to this problem.